Or I could draw a right angle here. Make a right angle with all of these. Okay? We call that the orthogonal distance. Okay? So the question is, which one is best, or is there some other method? And it turns out that the vertical distance, the purple distance, is the best. And we refer to that method as OLS, which stands for ordinary least squares regression. Okay? So the vertical distance is the best. Okay? Now I'm going to do a little exercise at the end of class. You're probably all going to hate it. And you're going to be like, I'll just miss that problem, I don't care, on the test. And then in chapter 14, after you've forgotten all this, I'm going to come back to it. I'm going to say, remember back in chapter 4, and you're going to groan. Okay? So this is going to be a fun day today. Okay, so in order to find the vertical, the ordinary least squares regression here, okay, you guys are familiar with your equation y equals mx plus b, right? From math 10, 50, whatever. Okay, so for some reason, statisticians like use different letters, and they come up with the equation y hat equals b0 plus b1x. It's the same thing. If you've ever wondered in math 1010, how did they come up with all these equations? This is how they did it. Okay, so I'm going to refer to the slope m because that's what you're used to, but in this equation it's also the same thing as b1. Okay, so the way that we find the slope is r times s of y over s of x. Okay, that's your new equation today. You're probably used to a different slope equation. We'll talk about that one later. Your y-intercept, you're used to calling it b. In my equation here, it's called b sub 0. Okay? That's going to be y bar minus m, or b1, times x bar. I like to use m and b because that's what you're used to. Okay? So, these are our new equations that we're going to use today. If you open up Canvas, go to your in-class worksheets, pull up worksheet 4.1. All right, and so we're going to use this data set, okay? So a golfer is chosen to swing a ball on a 70-degree day with no wind. You want to see if there is a relationship between club head speed and distance in the yard. So let's think about that for a minute. I'm not much of a golfer. But do you think that if I swing my golf club, the club head speed, is that going to affect your distance? So these seem like there's probably, you probably think there might be a good correlation here, right? Probably. Now what would be our first step in doing this? What did you say? Okay, so we did it. This is my data. So my first step after I have my data would be, what? That's the second step. The first step would be
correlation.
Chart. Create scatter plot.
Scatter plot. There we go. It even says it right there.
Oh.
Okay, we're going to do the scatter plot. Insert, scatter. I know I did this yesterday really fast, so we're going to slow down a little bit today. I'm going, oh, Megan, you're here. I have your quiz. I didn't give it to you because I didn't see you. How would what would make this a better graph? Thank you, Megan.
Oh, I'm so sorry.
Did you hear what he said?
No.
Oh, dang
I was
it.
trying to put a scatter plot in this.
So you ignored it, what the answer was from the crowd. What would make this graph better?
The numbers are on the y-axis.
What do you call that?
No, I don't know.
You click on this green plus sign, and then it says add axis titles. Okay? So what should I put for an axis title here?
Club head speed.
So club head speed, and how is it measured? Miles per hour, that might be kind of useful, right? And Megan, what should I put over here on my vertical axis title?
Yards.
Distance in yards. Okay? Now, what would be a good title?
Correlation of club head speed and distance.
There we go. I like it. Club head speed. Okay? All right. So, because we're short on time today, I'm going to let you use the cheater method, but you all remember how to do this manually, right? How would you calculate your correlation coefficient with the cheater method? Ashley?
The whole thing?
We're doing the cheater method.
Cheater method, oh, do you do equal correlation?
Oral, okay,
And then
parenthesis.
all your data.
Okay, so what do I select first?
Okay. You select your x's.
Okay, the x's, so we're calling club head speed my x's,
And you add a comma.
comma,
And you select all the y's.
all the y's, close our parentheses. Okay, so I got a correlation of 0.9387 on your test. I'm going to make you do this the hard way though, right?
What button do you push to select them both?
So you select the first one, then you press comma, and then you press the second one.
Okay, so you don't have to do anything.
You don't have to do any control.
Okay.
Okay? It's,
Jared,
okay, I was gonna say Jake.
on the test, are we able to allow to use stdev.s?
Oh, that's a good question. Yes. Okay? All right, so we found our correlation coefficient. Now you were jumping ahead to the next step here, right? Okay, so you were trying to find the slope. And in order to find the slope, you need to find the what? Standard deviation. So you can use either the STDEV or the .s. I always like that one, but it doesn't matter. Too fewer characters to type. So the standard deviation on the yards is 7.74 yards, and on your club head speed is 2.295 miles per hour. Okay. And so now to find the slope, Jared, do you want to take it away? How do I find the slope?
Divide the standard deviation of yards by the standard deviation of.
Okay. This is funny to me that you guys do these in backward order, but that's okay. S of y divided by S of x, and then what?
It's multiplied by what's
Multiplied by what's r?
Correlation.
Correlation coefficient, which is 0.9387. Okay? All right, so we found our slope 3.1661. Okay? So now, I want to say Ryan.
Yes.
Oh, I got it right. Okay? Ryan, I need to find my y-intercept, and in order to find my y-intercept, what do I need to know? What's the one in the middle? What is that? That's B naught. Okay, so by the way, I'm calling it M and B. On your equation, it's called B1 and B0. Okay? So I think this is easier to remember, but that's what it's going to be on your formula sheet.
So it's,
So what do I need?
this guy y divided 70 distribution.
Trying to get the y-intercept. We've already got our slope.
X times
So
close.
3.1. 6. What does y bar mean?
The average.
That's the mean. So I need to find the mean of y bar and the mean of x bar, right? So I'm going to highlight this. There's my slope. The mean of y bar is average, that stupid A word. Okay. First of this. And the mean of the slope is 101 yards. Okay? So now that we know all that, I think we can figure out our y-intercept. Okay? Can you help me do that, Ryan?
I'm still trying to type in, getting so I'm
You're not typing in the data, are you?
no, I'm trying to.
3 steps behind?
Yeah.
Okay, Catherine, you know what to do. Okay, what's y bar?
Weber is the mean of the y.
Okay, so I'm gonna click on this one, 266.75, and then what am I gonna do? I'm gonna subtract what's m. M's the slope, and in our case the slope is 3.1661. And what am I going to do next? Multiply by x bar, which in this case is,
101.875.
Okay, so essentially what this tells me, so I found my slope and my y-intercept. So my equation is going to be y equals what, Taylor? Y equals,
mx plus b.
yeah, what's m?
So our slope is 3.166, and then x is,
We're going to add,
so we add, I'm not sure which of these numbers.
I'm adding b, what's b?
I don't know.
My y-intercept.
Y-intercept.
Which is?
Okay, so that's negative 55.7.
Negative 55.7966.
79.
That's the equation we just came up with.
Can you show how you got B again?
This is right here, y bar, which is 266.75, minus m, which is 3.1661, times x bar, which is 101.7. Okay? So we just found that. Now, notice here, do you think there's an easier way? Do you think I'm going to let you use it? You can check yourself. Okay? What happened to my thing? Okay, so here's the easy method. You're going to click on a point. Any point will do. It doesn't matter which point you pick. Just pick a point. You're going to right-click on that point, and you're going to say Add Trend Line. Okay? And it's going to draw a line in there for you. And then you can say down here, oh, display the equation on the chart. Look at that equation. It's exactly what I wrote on the board. Is that not cool? Excel is as smart as you are now. Okay? Now, the other thing that I want to show you is it says display the r squared value on the chart. What do you think r squared is?
Oh, it's going to be our correlation coefficient.
Correlation squared, right? Okay, so that's simply your correlation squared. Now, in the book, they have a special name for this r squared, and they call it the coefficient of determination. I don't know anybody that calls it the coefficient of determination. Everybody calls it the r squared value. Okay? But it does have a name. Okay, the r squared value tells you the percent of variation explained by the model. Okay? So now as you look at this, okay, so this line is the prediction line that we would have predicted. Now, let's look at this for a minute. Notice I've got 2 dots here, okay? There's 2 times that I hit the ball 100 miles an hour, okay? One time it went 257 yards. Another time it went 263 yards, okay? Now I could have predicted, according to my equation, okay, I could have predicted that, okay? So if I plug it into this equation, okay, I'm going to get 3.166, so that's my slope, okay? I'm going to add for that, and then I could multiply that times my 100 miles an hour, and then I could add my y-intercept, which happens to be negative, okay? So, according to my line there, I would have predicted that that ball would have gone 260.8 yards, so about 261 yards, which is right smack dab in the middle, okay? Now, one time it went farther than that, one time it went less than that, okay? So what we're saying is this equation here is good enough to predict 88% of the variation, which means 12% of the variation is unexplained. So let's think about that for a minute. Okay, it says you swung with no wind, but what if there was a gust of wind while the ball was in the air? Maybe it slowed it down, or maybe it pushed it farther, it was behind you, right? Or maybe it hit a pebble when it hit the grass and it bounced forward. Or maybe it was a little wet there and it bounced forward, or maybe it bounced backwards, or whatever, okay? So there's a lot of other factors that could explain why we didn't get what we predicted, okay? So the R-squared value tells you the percent of variation explained by the model. In our case, 12% is unexplained, wind, pebbles, water, moisture, something like that. We'd probably explain that. Does that make sense? Okay? So that's what your R-squared is, simply your correlation squared. Okay? And in fact, just to prove that, if I take that and I raise it to the second power, I get 0.8811. Okay? Yes.
So when you were predicting, what did you plug in? It was B20 and A10 and...
So I took this equation here.
Okay.
This equation I wrote on the board.
Okay.
I took the slope, which was 3.1661. I multiplied it times my miles per hour.
Okay.
And then I subtracted 55.7966.
Okay.
Okay?
Thank you.
Now let's think about this for a minute. Okay, what if I were swinging and I swung the club 0 miles an hour? What would happen to the ball? It would not go anywhere, right? Now, according to my equation, if I stick a 0 in here, how far is the ball going? It's going backwards, 55 yards. Does that make sense? Okay? So, what this means is prediction outside the range is risky. Okay? This equation works really well if you're between 99 and 105 miles an hour. It doesn't work so well at 0 miles an hour. Or even 50 miles an hour, it might not work very well. Or at 200 miles an hour, it might not work very well. You might break your ball or your club. Okay? 106, that'd probably be okay. 98, that'd probably be okay. That's a little bit outside the range. It'd probably work in those cases. But if you get really far outside of that, not necessarily. Okay? So you got to be careful with what you're predicting. Okay? You know, if we were talking about child growth, a lot of times kids grow really fast and then they tail off. I should draw that a little bit differently. Okay? So you might have, that might be linear between there and there, but notice there's a big curve. Okay? So you got to be careful about this. You don't know what it looks like beyond your linear part. Okay? All right. So now let's just do some more predicting here. If I did that for all of those, I could copy that down. And now I could do what we call a residual. Okay? So you took the y equals mx plus b. What did you plug in for x? X, that's your miles per hour. So another way to write this equation would be your distance in yards equals 3.1661 times your miles per hour minus 55.7966. That's what your equation. So this is your y. This is your x, right? According to my scatter plot. Does that make sense?
Okay.
Okay.
Got it.
All right. So what I could do with my residuals equals your actual minus your predicted. Okay? So what I could do is I could say, okay, I'm going to take my actual 257, I'm going to subtract my predicted, which was 260. You'll notice that I was off about 3.8 yards. Okay? So that's a little bit of variation. Yes?
What was how did you make the prediction?
I used the equation on the board there, or this equation right here.
That's it.
So I just plugged 100 miles an hour
Right.
into that equation. I predicted it would have gone 260.8. It only went 257. I'm off by 3.8 yards. Does that make sense? Yes.
What was R again?
How's your correlation?
Okay, so R squared is the percentage of how much that can be off? Like how much?
So your R squared is the percent of variation explained by the model. So 88% of our variation can be explained by this. We call this a model. This is our equation.
Oh, 88%.
88% can be explained. 12% is unexplained. Okay? All right. So I'm going to find the residuals for all of those. Okay? Sometimes it's negative. Oh, except for, did you notice they're all negative in my case? What, I made a mistake, didn't I?
Did you have for the y-intercept in the prediction?
I didn't. That's why my mistake is there. Okay? So make sure when you're doing this. Oh, you know what? That's what I did. I forgot it here. Okay, these predictions were all wrong. Now they're right. Okay? Make sure you make that equation correct. You have the F for the slope and the y-intercept. I only did the slope the first time. I didn't do the y-intercept.
So how did you do the residual?
Residual is actual minus predicted. So 257 minus 260 is 3.8. Okay? Now, another thing I can do is I can square the residuals. Residuals squared. Okay? So if I take this number and I raise it to the second power, I get 14.54. I'm going to copy that down. And then I'm going to find the sum of my residuals squared. My sum works out to be 49.85. Okay? Now I want to put that number in your back pocket for just a minute, and I'm going to explain that in a minute. Okay? But my sum of my residuals squared is 49.85. Does that make sense? Does it make sense what I did, maybe not why I did it? I'm going to explain why in just a minute. Okay? So I was looking here at Marissa, and she looked very skeptical. And she said, you know, that's not how we did it in Math 1010. I don't like this equation, and I don't like this equation. Because it just looks like statistics mumbo jumbo. Marissa, do you remember what was your slope equation in Math 1010, 1050?
Slope is rise over run.
Slope equals rise over run. Do you remember the actual equation?
Y over X.
It's the
Is it
change in
actual
y
equation? Oh, yeah,
over the
delta
change in
over
x,
delta.
which is. Anybody remember that equation? There we go. Y2 minus y1 over x2 minus x1. That's what you remember from Math 1010. So Marissa, the skeptical one, says, I don't trust that thing. I think there's a better way. And oh, look, two of those points are on that line anyway, I think the math 10-10 way is better. You were thinking that, weren't you? We're pretending that she was thinking that. Okay, so as she looks here, she says, well, look at my residual. That's only off a third of a yard, about a foot, okay? I'm gonna highlight that and say orange, okay? That was a really good prediction. And we're gonna look at this one here. This one here was also only off a third of the yard, about a foot. That was a pretty good prediction, right? So Marissa, she says, I don't want to do this statistics crap. I'm going to do it my old-fashioned way, okay? And so she says, okay, I'm going to find the slope. In this case, it's going to be y2 minus y1 divided by x2 minus x1, okay? You guys are all familiar with that? This is the math 10-10 way. And look, her slope is really close to the slope I got, right? Okay? So that makes you think pretty good. That's pretty good. Okay, so now if I know the slope, in this case it's 3.166666, it goes on forever. How would you find the equation? An equation like that or something else. Okay, this one you need to have a y-intercept. I don't know the y-intercept. Is there another way to find the equation? Are you recording? You're supposed to warn me. You guys remember? Remember any other equations?
Y minus Y1 equals N times X minus X1.
There we go. What's that called? It's called the point slope. She got the name wrong, but she got the equation right. Okay, study with Alexa. She knows what she's doing. Okay, y minus y1 equals m times x minus x1. Okay, if I know any point, and I know like 8 of them over there, and if I know the slope, I can do the math 10-10 way. Now I'm about to show you it's not as good as my way, but you're probably more familiar with this, right? Or at least Alexa is. Anybody else remember this? Okay, Cooper. All right, so, because you guys don't trust me, right? No, Cooper especially, he's wearing a Yankee hat, that's why. Okay, all right, so if I've got a point and a slope, I'm gonna pick any point, okay? So I'm gonna say y minus, let's say 277. I'm gonna pick this first point in orange here. Y minus 277 equals m, which in my case is 3.166667, times x, oops, I need a parenthesis, times x minus 105. Okay? Are you familiar with the point slope? Now I could add, if I want to get a y equals here, I'm going to say equals 3.166667 x times x minus 105 plus 277. Just a little bit of math there, right? Okay, does that make sense? Okay. Now, I just remembered something else I forgot to do. Okay, before I do this, I'm going to do this prediction in just a minute. I just want to remember one other thing. So another thing that you're going to want to do to make sure that regression is a good idea is you're going to want to create a residual plot. How you do that is you're going to take your speed here, and you're going to hold the control key down, and you're going to click on your residual column. Okay? We're going to insert, I'll quit locking up on me, insert a scatter plot. Okay? Now, for the residual plot, you want a null plot. You want a hamburger there. Okay? It's bad if you get something like this, or something like this, or we refer to this one as the megaphone. Okay? If you see some sort of a pattern in there, that's bad. That means you don't have constant error variance. And therefore, don't use ordinary least squares regression. Okay? Now, in our case, do you see a pattern in there? So that looks like a no plot. Is that a good thing? In this case, that's a good thing. Now, I'm not going to be so concerned about you labeling this. This is just your residual plot. But I want you to be able to make that and then say, yes, ordinary least squares is good, or no, it's not good. Okay? All right, we're going back to Skeptical Marissa. Okay? We're going to plug this in and we're going to see here in this case. So I'm going to take her slope here, and let me highlight this in orange so that we can see the different method here. Okay? So this is going to be the prediction thing. So we're going to take her slope, we're going to multiply that times the club head speed, we're going to subtract 105, and we're going to add 277. Okay? So here's the interesting thing. She predicted it would have gone just a tiny bit farther on hers. Okay? We're going to do that for all of these. Okay, whoops. Why did I get the value there? I forgot to F4 everything. So I want my slope not to change. Everything else can change. Okay, so we're going to check her residuals. Okay, that's going to be the actual minus the predicted. We're going to copy that down. Okay, and then we're going to find the sum. Nope, we're not. We're going to find our residual squared, and then we're going to find our sum. Now notice some of those are right on the money. Okay, we're going to compare her residual squared to my residual squared. We're going to get 50.8. Okay. That number is higher than that number. So what I've just proven to you is her method isn't as good as mine. Okay? Ordinary least squares is going to have the smallest sum of your residual squared than any other method. Okay? That's what you're looking for. You're looking for the smallest sum of your residual square. Okay, so your quiz tomorrow is going to be on 4.1, 4.2 and 4.3. You're going to have to know how to create residuals and all that stuff. Know how to find your slope, your y-intercept, residual squared, your coefficient of determination, all that stuff. You had a question?
I was just wondering how you made your residual plot. Did you just do the log of
It's the club head speed, in this case your x versus your residuals. Okay, you could make another one there.
Will you put that online?
I will. Any other questions?
Are we doing the quiz on Excel?
No.
No. Okay.
So quiz tomorrow in 2 sections.